This is lecture 16. I'm happy to continue talk about the technique of grid free. Last time we finished here, right? We stop here, so we need to continue to talk about how to implement the programming component of the peer, right? We need to continue to work on that. I'm not sure whether you have you agree with me. I'm not sure whether you agree with me or not. If you have ever programmed with some other techniques or learn some new techniques, any other programming techniques, or at least if you have ever used Akka, Go, Erlang, and between those techniques, I think Akka is the best one. In the area of I call it asynchronous and distributed programming paradigm. Maybe in such a programming paradigm, I think Akka is best. Go, Erlang, Akka, and even grid free, all of them belong to this programming paradigm. And between the three one, Akka, Go, Erlang, Akka is the best from my point of view. But after comparison, I think I have already made a lot of comparison between my system and Akka. There's three fundamental differences, right? I do not need to repeat that. But I think another important feature I want to tell you is that if you learn Akka, if you read the book of Akka, the tutorials and a lot of papers about Akka, you can see almost all the distributed system, almost all the programming technique, including Akka, especially Akka, Go, and Erlang, this technique must tell you something new to establish a distributed system, but they do not explain where these techniques come from, how to design these new techniques, how to design this new programming paradigm or programming component. For example, in Akka, there is an idea called cluster, right? Cluster is a lot of computers can organize together and work in a way that more powerful. From the user point of view, it looks like a single computer with rich resources and more powerful than any single one. Yeah. So the cluster is a powerful computer organized by infinite number of computers. So, however, from my point of view, if you have read the book tutorial about Akka, it does not explain how to implement such a cluster. They just tell you cluster is already there. You just use it, but it does not mention if we want to change the cluster, what we can do. If we want, what is your approach to implement such a cluster? It does not explain that. I don't think it's good enough, right? At least it's not self-contained. Akka is not self-contained techniques because if a new programming component is required for one particular computing environment or scenario or computing cases, we have no solutions. Akka does not provide any solutions for us to deal with such a particular application. In short, that means Akka works on a predefined distributed computing environment, right? You must agree. I think that's reasonable, right? That makes sense because it does not explain anything about how to create a cluster or how to create any other programming component with the techniques from Akka. Actually, I think it's impossible. It's impossible for Akka-like system to implement new programming paradigm. Programming component with its own with own primitives. That's a very important disadvantage of such programming techniques, right? So that's why why it does not talk about that, because it does not promote and that does not put forward any distributed primitives. That is it's that those distributed primitives, it does not propose any distributed primitives that can be programmed that can be used to program any new techniques for one particular distributed computing environment. He only proposes in some so this term is not property describe the text. It's only define some basic its own fundamental programming component. It's Akka-like system. From this perspective, Akka-like system do not propose any primitives. Primitive is defined in such a way, from my point of view. Primitives should be used to define, to program, to implement any additional or any new programming component to deal with the one particular distributed computing scenario. So, however, I don't think Akka can do that. Akka is good enough to do that. Akka only have an actor. This is a fundamental programming component of Akka. I already mentioned that in previous classes, but I don't think actor can play the role of primitive. Actor is not primitive because actor can only be used to establish constructs, applications for one predefined environment. If the environment is changed, actor can do nothing. That's my opinion, right? So if in Akka, the actor actually is implemented with Java, now JSE. Okay, right? That's why Akka does not talk about how to implement its cluster, because its cluster is implemented with Java SE, Java Standard Edition. So it does not make sense to explain that, because this tutorial talk about Akka only. It's not necessary for the author to describe how to use Java to implement such a cluster. That's a reason, right? But I don't think it's that's why I don't think Akka is not self-contained distributed programming paradigm. That's the same for Go and Erlang. I think most distributed asynchronous distributed paradigm have such a feature. That's why I think GRID-free is much better against that, right? Compared with is much better. I have a lot of have at least GRID-free is a self-contained one. This advantage is more important for programming paradigm to be a new techniques that can cover all the existing techniques, can replace all the existing programming paradigms. That's a very important foundation for techniques to be independent. Okay, let's continue. So last time we finished, we stopped here. So next time we will continue to work on the peer. The peer is a combination of the CS client and the CS server. So last time we have already showed the code of CS client and there. So in this time I will focus on how to program the peer. But when we program peer, actually the peer is a combination, aggregation of the CS client and CS server using their patterns directory. However, because we need to make the code simple, we need to make the code clean. So in this way, I do not just aggregate them straightforward. I use some object-oriented techniques to implement such a peer. Because it's object-oriented techniques is a good way for us to encapsulate all the techniques to provide a clean interface to make the code looks beautiful, right? So in this way, for that, CS server in my implementation plays a role as a parent class. So the parent, because the CS server is a parent class, so all the features of the CS server is inherited by the peer. The peer must be a CS server. Additionally, I also encapsulate the compose, maybe I can compose, right? The CS client also be composed into the peer of the class of peer. So that makes the code much better. So okay, we can take a look. We can take a look at the code later. Okay, here you can see although we just need to make combination we need to combine the CS client and the CS client CS server. We also need to, it's not good enough. Although the combination is a peer, however, we still need to consider another issue for registry, because peer is a programming component we can use to program large-scale distributed system, to program scalable distributed system. That means in one particular distributed system, it must contain multiple peers. Maybe sometimes the number may be infinity or unlimited. If so, we have to use a register to collect the IP address at least. We talked about registry service last time. So when you implement such a peer, you need to in addition to the combination of the CS client, CS server, you also need to consider how to register the peer when the peer is initialized, when the peer is started. So that's what you want to do, right? This is so that if you do not consider this issue, the peer is not good enough. Okay, so here it describes something I think we have already discussed those issues. And AA means advanced API. So when the advanced API is finished, I think we also need to provide patterns for that. So those new advanced API can be reused. But I think the pattern of the peer should be the pattern of the peer. Peer is we just mentioned, we talk about how to implement the API of peer, but we in the next step, if the API is implemented, we also need to program that, right? We also need to program such a system, right? So for that, we need to provide a patterns. So a pattern, that's the solution of GridFree. If we just implement the API, it's not good enough. In GridFree, all the API should have a pattern. Fortunately, for this case, all the patterns, for the peer is just reuse the CSS, RR, ARE, SRE. This is a combination, right? So you don't need to invent anything new. I want to tell you for the pattern issue. So in the next step, you can see all the APIs. Although there are a lot of APIs in when you program a distributed system, you have to implement numerous APIs because of complexity of the distributed system. Fortunately, the pattern for those APIs are very limited. That's Sprar, right? That's Sprar. What Sprar mean, right? We talked about this term before. Sprar means steady. If you have no idea, I just want to repeat. Steady pattern for rich APIs. Sometimes maybe we use with. It doesn't matter, right? I think for is better. Sometimes use with, but the acronym is SPRAR. That's one of important foundation, one of the three foundations of GridFree. If the SPRAR, no such feature, then it's impossible for us to provide simple enough programming language in the future. In the future world, I want to design some syntax to cover all the APIs, all the programming techniques of GridFree. Then developer can use such a new programming language to design any distributed system. To make this language as simple as possible, we need to have such foundation. Otherwise, if the pattern API are rich and the patterns are rich. That means we have two. The syntax or semantics of the language must be complete. Then it results in the difficulties to program distributed systems. So that's the next step I want to do. Okay, let us take a look at the code. We can see the code here. Last time stop here, so let us open the project again. Peer is should be on the peer is a combination of client and a server, but I put it, but it looks more like a server because the server side is difficult to be designed. Server side need to consider a lot of ISO concurrency, resource reuse, scheduling, a lot of issues. So the server side is difficult to be created. Server side occupy the maybe most of the code on the server side. Most of the code on the peer is a server code, so I put it on the package in a package of server. Okay, let us take a look at this code. You can see I designed a new class. It's called abstract CS server. It actually is a CS server. It's almost identical. You can see this code identical to CS server because now it looks work as play the role of the parent of the peer. So I create a new code. We call abstract CS server. Actually, the same. You can take a look at this code if you like. It's almost the same as CS server. Open this one. Almost the same. I just implement a new class, but the code inside them is almost the same. I don't want to explain that in detail, okay? And then I implement another one. It's called register. So when we create such a system, we need to have a CS server, register. What else? CS client. So only three. We just aggregate the three portion of our code. Then we can create the new programming component. This one is represent is originated. This one is one originated from DP, right? This one is also the CS client is also originated from the DP. However, this one. What about this one? This one is distributed knowledge. So actually, when you distribute, I have already talked about this before. So when you implement a new AA, you should consider distributed knowledge first. We talk about that. Without distributed knowledge, how do you know what you should implement, right? This is this is the common sense. This is easy to be understood. And the next, you just use DP or other relevant AA. But I think because those techniques are easy to be programmed, I talk about that because of the design patterns, because all the patterns can be reused. So all the patterns are compatible for different computing environment. So those stuff those techniques is easy to be programmed. So you just focus on, actually, you just focus on distributed knowledge. So that's then you can implement any new APIs, any advanced APIs with GridFree. When you describe this distributed knowledge, you don't need to you just use the regular description. You don't need to use any. You do not need to think about any distributed techniques, distributed computing environment, the threading, the computing resource reuse. You just focus on the description, the knowledge description. This looks like business logic. You just focus on business logic. And when you create an enterprise system, you need to focus on business logic. However, because we already have the distributed primitive and some other advanced APIs, so you can focus on distributed knowledge description. Then the programming efficiency must be raised, must be guaranteed high distributed efficiency, distributed system development efficiency, right? So that's a very important techniques why GridFree can support rapid system development, right? Okay, let's continue to take a look at the code. I made a lot of revision here, right? You can see a lot of code comment out. This is the builder pattern. We see that before, right? The builder pattern. Because so first for up here, there must be a lot of parameters should be set to initialize it. Register should be initialized here. The client should be initialized, right? And the sales server should be initialized. This is the builder pattern, right? Builder pattern. Then some parameters, some method. Some method I provide here is starting ID, IP address, port number. We can also assign another port if we need. Okay, set port. Okay, and registry server IP. Okay, because there is a register server exists for us to register IP address of one peer. Thread pool. Maybe this thread pool need to be shared. If we want to share the thread pool, we can expose it. Start, right? Start. So we need to start this one. When we start this peer, we need to perform register. To simplify this explanation, I don't want to explain detail of the register, and it's very easy. So when a server is when a peer started, it send a register request to the register server. Then the register server, this is will keep its IP address and its name on the server. Keep the IP address and the name on the server, and then when other peer started, when one particular peer want to it's attempt to connect it with any other ones, it can search on the Regis server based on the name of the peer, the ID of the peer. So based on if the name of the peer is provided, then the IP address can be obtained. Then based on this IP address, two peer can be connected and interact with each other. Okay, that's what the register does in my system. Then started. This is actually the CS server is started, right? We initialize the peer. When we need to initialize the client, when we need to initialize the client, we need to provide a thread pool. The thread pool, right? So server needs a thread pool. The server needs a thread pool, and the client also needs a thread pool. They both share the same thing because this thread pool is obtained from the server, right? Because it's super. Super is the parent class is the CS server. Stop. Okay, stop. Before we stop, the first step we need to do when we stop, we need to unregister. Then collect the resources of the client. Then stop the server. Okay, next, what we can see here, notify. This is the pattern, right? From the developer's point of view, this is the pattern of this sync SRE. SRE means sync remote eventer. This is that pattern, right? This is another pattern. This pattern very simple, so maybe you don't need to pay much attention to that. It's very easy, right? Very simple pattern, very easy to be understood. Reader, right? Okay, some other parameters also implemented here, but they maybe when we use it, we'll explain that. So you can see here, that's why I implement such a that's a way I implemented the peer. So through the implementation, you can understand the technique of the grid free. They just use the distributed primitives and the distributed knowledge to implement this new peer, this new programming component. In the following classes, I will show you how to implement all the new distributed advanced API in the following classes. I will explain in a similar way. That's different from any other asynchronous and distributed paradigms because they do not have the idea of distributed primitives. That's why they are not called self-contained programming technique. Okay, let us take a look at the code, how we can use it in one particular case, right? You can see peer is used a lot of projects, package, a lot of code use this one, and maybe what I want to show you here, because peer is a very important, right? Peer is a scalable programming, distributed programming component. That's the foundation of a scalable distributed system. So it uses a lot of places. So I want to show you the first example. This example is here. It's called P2P, right? If you can see here, there are for package related to the first example. For package, the first one is registry. This is the implementation registry. I talk about this concept, right? And the code you must have see it. And because it's just implemented with classic DP on the server side, right? All the DP on the server side can, if you want to implement such a registry, you can always use this all the API on the server side. We already implement some examples. So if you want to implement the registry, you can use just no new technical stuff here. You just use the distributed primitive on the server side. We already talked about that. The difference is that application level is different because this server is used to keep the IP address and the name of the peer. So that's easy. So I don't want to explain this stuff in detail. Next, you can see here, right? This one is a peer. Let us take a look at this code. Then I want to run this code to show the peer-to-peer system, to show the demo how the peer-to-peer system is executed, the most important feature for such a system. Okay, this I want to do next. But before that, I want to show you code, and you can browse the code and take a look at the code, and you can see it's easy to program this code. You don't need to use some anything new to when you don't need to spend much time to investigate or to do research how to use such a new programming component. It's very easy. If you have ever seen the code we programmed or we show you before, you must understand the code. It's easy for you to understand the code. Okay, let's take a look at this one. We start from here. Start chat server. We implement another type of chatting application using peer rather than the CS class. We based on a peer-to-peer architecture to implement such a chatting application. You can see it's a very different thing. There are different features, different implementation. However, fortunately, the code looks similar. That's a very important feature of Grid Free. Okay, let us take a look at it here. We start from the start. Open the code. Start chatting peer. Right. The code is opened. However, you can see you must. I think if you have ever watched my video, you must have ever seen such a code. If you forget, let me show you here. Okay, let us open the code here. Open another example. For example, here, multiple, right? Multiple. This one, if you want to, you can select this one. Right? I just make a copy from the most of the code from the chat client. This is the peer, right? Because this peer need to interact with another peer. So this I do not change the user interface. The interface is the same. Actually, the most other code also same. The most important code is here. right? Peer, right? Chatting peer. This is the chat reader or chat eventer. However, because this peer is a combination of the event and the reader, right? So we just need to initialize one singleton, because it already contains not only the reader but also the eventer, right? This CS client it already encapsulate all the clients API, and this one does not exist, right? This is scheduler. Why do we need to have a scheduler for this case? That's easy to be understood. How? Because as a peer, the peer is not only a CS client but also a CS server. So the client different from this is the pure client for this distributed node. It can only send a message to the server, and if they're chatting, the interaction between the two clients, each client need to perform polling. So this one is used to send the polling request periodically, right? This is if submit method is invoked, then this one checker is means send the polling. Checker is used to send the polling message to the server, right? To this is the polling, right? Polling is here. Here, right? This is polling request, right? Here, polling new chats, right? So here, this one is used to send the polling request. However, for the peer, that's a different thing. The peer can send include the peer is able to perform some the same action of a client. So the peer can send notification as well as a request. The peer is also a server. So the peer can, on another side, the peer can also receive information. The IP address can be obtained from the registered server. When the IP address is available, the peer can send the information to the one it want to perform a conversation. It want to chat, right? So no polling is required. For peer-to-peer architecture. So such a system, because of no polling, there no something that should be executed periodically. So they can the instant feature is much better than the CS client, right? So no polling is required. Then this one, displaying a menu, that's easy, right? And after that, the system is terminated. So here, and you can see, take a look at this code. You must have ever seen that, right? What about this code? This code is borrowed from say starting point, right? Starting point. Let us see this one. Right? Here there is a while loop. The while loop is here. It's also here. They're same thing. So you can see here this code starting chatting peer is a combination of this one and this one, right? This is the client, this is server. Combine them together, we can form this code. That means the design patterns are same. Design pattern, no design patterns are invented, although we create a new programming component, the peer. Right? Let's continue to look at the code. Open this code. We can prove in this case continually in the following discussion. You can see, we open this code, right? Open this code. Chatting peer. There are two fields, two attributes here. The first attribute is the peer. The next attribute is chain. Means management. Chatting, not chain. Chatting management server dispatcher. Let us open this code. That's the same, right? That's the same thing. At least very similar to each other. Actually, they're the same. It's just a straightforward aggregation. What I have shown, according to what I have shown you, you must agree with me. This programming is a way of straight aggregation. Okay, straight aggregation. That straight aggregation means we prove the feature of SPRA, right? That's the base. That's why I noticed this is, that's why I want to propose the idea of SPRA. In the other classes, in the near future classes, you must see the similar phenomenon. Right? Okay, that's the same thing, right? The code looks very similar to each other, almost identical. The difference here, because this is a application level stuff. However, there's no such there's no application level here. Why? Because the register server take this role. Register server perform something registry and on the server. So account is not useless here. So application level is different. That's normal, right? Application level are different requirements. So application level, I do not care about application level. However, the system level, distributed system programming level, almost, at least the pattern almost identical. The private session, the private chatting session is not here. This one is used to keep the chatting message on the server such that other clients can send a polling request to access all the new chat message. However here, because the chatting, the peer can interact with each other without polling, so this one is not useful in this case. Okay, this one is not useful. So when we start this peer, we do not need to care about private chatting session. Oh, there are a lot of, when you create, when you need to initialize a peer, a lot of parameter is required to be initialized. Why? Because we are required to initialize the peer. We also need to initialize the CS client. We not only need to initialize the server, we also need to initialize the CS client. So all the parameters for the client, for the server, should be set here. For the asynchronous, for the client, the synchronous remote eventer have a lot of parameters. So there are a lot of parameters used to set the asynchronous remote eventer. You can see the parameter almost the same, right? It's a parameter almost the same. And those parameters of some of the parameters here, maybe from here. This is for the server, right? But here, these ones are those parameters are for the client. A straightforward aggregation, right? Okay, then the peer is started here in this line. Next, what should I do? One difference, important difference is here. We need to perform something. We need to interact with the Redis server to ensure the port number. Actually, why do we need to do that? That's also the distributed knowledge. So when you do something, you need to focus on. You must make sure the distributed knowledge. This one is used by the peer to ensure whether its port is unique, no conflicts between multiple peer. If the multiple peers run on a single computer. I'm not sure you understand or not. This is distributed knowledge, not related to any system level implementation. If two peers are executed on a single computer, then it's possible for them generate the conflicts on the port number, because they already have the same IP, because they run on the same computer. So if the port have conflicts, if the code conflict with each other, then it will generate exception. It's not allowed for TCP programming, right? The PTT protocol. So this one is just to make sure whether there are some conflicts between the server side. There's some port conflicts on one particular computer. So we need to do that. Usually, in the practical, only one peer is executed on a single computer. But in some cases, especially for us, we need to show some demos. Usually, it's not necessary for us to deploy those code to multiple computers. So usually we run this code on a single computer, because all the applications right now I show you are lightweight ones. So I don't want to use a lot of computers to make the system deployment difficult. So I just want to show you a simple sample. So in our case, a lot of peer must be executed on a single computer. So this line is very important. But if you want to do that, it's easy, right? You just use what you can do that. You just use reader to do that. Reader, right? You can perform a read. Read is originate from remote reader. It's also one of the API from the distributed primitives, right? So you can see here, my system is still self-contained. Okay, next. This one is easy to be understood, right? This one is easy to be understood. This is a classic, a typical CS server. Next. Okay, here, there are some lines here. These lines, this is to perform reading. This one is used to send a synchronous notification. This one also used to send the notification. You can see here, these lines, these statements are programmed with the design patterns on the client side. This code, these lines are created based on the CSS pattern, and also include some pattern from the client, because the client is also need to be initialized. There's the peer contains some in client, some CS client also include. So therefore you must according to the introduction of this code, we haven't finished that because we have not talk about this one, right? But according to this code, you can understand the programming is straightforward aggregation. No new patterns are invented. Let us take a look at the code. So because time is up, we just want to take a look, and I will explain that in the next classes. But if you open this code, you can see here, it is complete. It is completed the same. They are identical. They are identical to this one, right? The code is identical, but it's simple. Why is simple? Why the peer is simple here? Because the peer is not required to process incoming polling message. No polling. So all the polling code is removed. And the peer is not required to perform registry. They're not required to create any account for its partner. So it's just focus on some programming the code for notification, chatting, for chatting, add partner and send the chatting message. So this code looks simple. More important, what about the design pattern? The design pattern is complete identical, equivalent to each other. Okay. Next time I will run this code so you can understand the peer-to-peer architecture and deeply. And I will also show you example. I will program this code, program application based on the peer-to-peer architecture. So I hope you can follow my classes and implement your applications based on this same architecture, peer-to-peer. Okay, that's all for today. Thank you so much. See you next time.